Good morning and welcome to this next lecture on vibrations of plates and shells. So we are looking at the response of a simply supported cylindrical shell. To a point force. And we said we have to look at the response of two sets of natural frequencies, I mean two sets of mode shapes. These two have the same natural frequency, omega mn is same, that is important to note. Okay. So now what we have is that if you remember the form of the equations, we have L1 let us say, then U1, U2, U3 the spatial operator, then we have minus lambda U1 dot minus rho h U1 double dot is equal to minus Q1. Okay. And if we temporarily leave out the damping and the forcing term, what we have is L1, U1, U2, U3 minus rho h U1 double dot is equal to 0. Okay. So now if I substitute this U1, I mean I should probably stick with, yeah, let us stick with 1 U1 and yeah, here I will make a change, I will make it Ux U theta, Ux U theta. Okay. Please get used to it, 1, 2, 3 and x theta and 3. Okay. So let us say Ux is equal to now eta mn and Ux mn, U theta is same eta mn, U theta mn, and U3 is eta mn U3 mn. Okay. So this is one mode shape into e to the power j omega mnt e to the power of j omega mnt e to the power of j omega mnt. It's a one natural frequency. Okay. Then what I will get here is, for this case, is I will get L1 Ux. Okay. Well, let me give an index here, mn. So Ux mn comma U theta mn comma U3 mn, okay, will become equal to minus rho h omega mn squared Ux mn. That should be evident from here. Okay. This is my Ux. Okay. So U1 is Ux, U2 is U theta, U3 is U3. So if I alternate, please understand. Okay. So this operator on this mode shape is equal to this. Okay. That is what we did earlier also. Yeah, that is what we did here. Okay. So this into this plus this into this plus this into this is equal to 0 when we did. Okay. So that is exactly what is happening over here. Okay. Because this Ux mn carries with it a mn by c mn and so forth. Okay. They are carried within it. So this is what will happen. this L1 operator is equal to this, and we are going to use this. That is the reason I am trying to stress. Okay. So now what will happen is that as a result of this, in this original equation, okay, if I substitute, let us say u x as a summation, the full ux now as a summation of mn eta mn of t, and let us say ux mn of x theta, okay, and u theta same form eta mn of t u theta mn. Now I am substituting the full displacement, not single modes, then u3 as a summation over mn eta same mn of t, is called the modal participation factor, u3 mn of x comma theta. If I substitute this into this, okay, and then use this fact, then what I will get is summation over mn rho h eta mn double dot plus lambda eta dot mn plus rho h omega square mn eta mn into u x mn is equal to qx. Okay. So this operator has brought in this term. So this term is this term over here, okay, and the other two, one time derivative on u1 or ux and double derivative on ux, double derivative brings this, one derivative brings this. Okay. So this is the form the first equation will take. Okay. Similarly, the second equation will take the same form here. Okay. Here it will take u theta mn is equal to q theta. The third equation will take rho h eta mn double dot etc. the same, but u3 mn equal to q3. Okay. That is the difference between a plate and a shell. Okay. So now what do we do? What we do is we multiply this by a different mode, u x r s, u theta r s, u3 r s, multiply, and then integrate over the shell area, with the appropriate a1, a2, d alpha 1, d alpha 2. Okay. So for the shell it is a1 is 1, a2 is a, dx, d alpha is dx, d alpha 2 is d theta, and the same on the other side. So you multiply ux rs, u theta rs, u3 rs, and you integrate. Okay. Now you can see the result. I am going to write on the next page. We are going to add this up. If we add it up, we get sigma m sigma n rho h eta mn double dot plus lambda eta dot mn plus rho h omega square mn eta mn, and here we have integral over the area u x mn u x rs plus u theta mn u theta rs plus u3 mn u3 rs into a dx d theta is equal to, on the other side, integral over area qx u x rs plus q theta. These are forces per unit area in each of the directions. U theta rs plus q3 u3 rs a dx d theta. This is the orthogonality condition, if you remember. Okay, m must be equal to r, n must be equal to s for this to be non-zero. If any one is violated, this is 0. Okay, and therefore out of mn, r and s are picked out, but r is equal to m, s is equal to n. Okay, so the mnth fellow is picked out. So what I get is, I get rho h eta mn double dot plus lambda eta mn dot plus rho h omega square mn eta mn is into, okay, gamma mn, or sorry my mistake, nmn, that's even using that, nmn, okay, is equal to this area into this forcing term. Nmn is integral over area u x mn squared plus u theta mn squared plus u3 mn squared a dx d theta. How does it look like? It can look like a mn by c mn squared cos m pi x by l squared cos squared n theta plus b mn by c mn squared sine squared m pi x by l sine squared n theta plus sine squared m pi x by l cos squared n theta. This whole thing inside this. Okay, so that can be nmn. It's for one set of modes, set 1. Okay. Now we are going to look at only transverse force. So qx and q theta will temporarily put it out, set to 0. Okay. So what we will get is rho h n eta mn double dot plus lambda eta mn dot plus rho h omega square mn eta mn is equal to 1 over nmn integral over area Q3 into U3 mn A dx d theta. So, we are back to what happened with plates. Okay. So, we will write this as eta mn double dot plus twice zeta mn omega mn, okay, eta mn dot plus omega square mn eta mn is equal to 1 by rho h n mn and this term. Okay. So, let us see now. So, we will do it first for so this we are going to do it for harmonic case, right. So, Q3 has a harmonic component in it. Yeah, e to the power of j omega t, forgot about it. Okay, Q3 has e to the power j omega t in it somewhere. Each of these is harmonic. Okay, there is a harmonicity built into each of these. Okay, so again my f m n star, the harmonic part kept outside, is this area Q3 spatial descriptor U3 mn A dx d theta divided by rho h n mn. Okay. Then from here you get to gamma tilde, then from there you get to eta mn. Okay. So, we will see how that goes step by step. Okay. So, let us see here. I have my set 1, mode set 1, let us call it mode set 1. So, if so I is describes the type of natural frequencies, type of motion actually, type of motion and the related natural frequencies. Okay. So, if I is 1, we will know it is axial. If I is 2, we know it is torsional. If I is 3, we know it is transverse. Okay. So, that means what? The coefficients ux will have a coefficient a m n I by c m n I. The u theta will have a coefficient b m n I by c m n I. Okay. So, let us see, the first set is u x m n I, and first set is a m n I by c m n I cos m pi x by L cosine theta u theta m n I first set b m n I by c m n I sine m pi x by L sine n theta, then u3 m n I first set is sine m pi x by L cos n theta. This is the first set. Okay. Now let me let me write the second set also. Okay. Let me write the second set here. The second set is set 1, is set 2 is u x m n I. The second set is a m n I by c m n I cos m pi x by L sine n theta u theta mn I second set is minus, please remember, b m n I by c m n I sine m pi x by L cos n theta, and u 3 m n I second set is sine m pi x by L sine n theta. We will work with the first set now, okay, set 1. Set 1. Okay. So now what is n m n I for the first set? That is also important. Okay, and hold on, before that, okay, let me say that the forcing x comma theta comma t is some force amplitude harmonic delta theta minus theta star by a delta x minus x star. So, it is applied at theta star and x star, so point force. Now, n m n I for the first set is integral 0 to twice pi integral 0 to L a m n I by c m n I whole squared cos squared m pi x by L cos squared n theta plus b m n I by c m n I squared sine squared m pi x by L sine square n theta plus sine square m pi x by L cos square n theta a dx d theta. Okay. If you now carry this out, when n is not equal to 0, n m n I 1 will turn out to be a m n I by c m n I whole squared plus b m n I by c m n I whole squared plus 1 L a pi by 2. Okay. When n equal to 0, I get n m 0 I first set as a m n I by c m n I whole squared plus 1 into L a pi. You can check this out. Okay. Anyway, n equal to 0, this goes to 0, so you can check it out. Now, for n equal to 0 or n not equal to 0, sorry, f m n I first is 1 over rho h n m n I first set integral 0 to twice pi integral 0 to L f3 or f, sorry, keep it as f 1 by a delta theta minus theta star delta x minus x star sine m pi x pi L cos n theta a dx d theta. This becomes f, this a goes with this a, f by rho h n m n I 1, okay, and then this takes out the cos term, this decides the sine term, so I get sine m pi x star by L cos n theta star, okay. So this covers n equal to 0 case also, then nothing special need be done, covered, okay. If n was coming in the denominator and n goes to 0, we had to deal all those things, limits, etc. But no problem. I can set n equal to 0. So this works when n not equal to 0, it works when n equal to 0. Okay. So then this is what I now call actually the star, okay, in our notation when we do harmonic. When we do the harmonic case, we are putting a star, okay. So let us see now what is my ux for set 1 is summation over I 1 to 3 summation over m going from 1 to infinity summation over n going from 0 to infinity, my f star m n I first set into, okay, gamma has to come in, and gamma comes in with what, divided by omega square m n I minus omega square, okay, plus j twice zeta m n omega m n omega, okay. This was my gamma tilde m n, if you remember, gamma tilde m n, okay. Then if I put in e to the power j omega t, then that is my eta mn, and eta mn should be multiplied by the mode shape, which is a m n I by c m n I cos m pi x by L cos n theta. Okay, I hope you got the steps. We had f star mni, we computed on the previous page, okay. If I divide that by omega square mni minus omega square plus j to zeta mn omega mn omega, I get my gamma tilde mn, I multiply that by e to the power j omega t, I get my eta mn. Then eta mn multiplied by the mode shape, corresponding mode shape is eta mn into mode shape. Then I have to sum it up over mn. Okay. Here I is extra because I could have 3 different sets in the 3 different directions. Okay. So this is fmn, this with this makes it gamma, with this makes it eta, eta multiplied by the mode shape and then summed up over im and n, that is ux. Then u theta which is the first set is again summation over I running from 1 to 3, summation over m going from 1 to infinity, summation over n going from 0 to infinity, same f m n I 1 star, but this time I have different theta directional mode. So this is also the same omega m n I square minus omega square plus j 2 zeta mn omega mn omega into b m n I by c m n I sine m pi x by L sine n theta, and u3 first set is similarly triple sum f star m n I 1 e to the power of j omega t divided by this frequency term. Okay. Then sine m pi x by L cos n theta. Displacement with set 1, we are done. Okay. Now displacements with set 2. Set 2. Okay. The load is the same, q3 x comma theta comma t is some amplitude of the force, harmonic delta over a theta minus theta star delta x minus x star, then n m n I second set is integral 0 to 2 pi integral 0 to L a m n I by c m n I whole squared cos squared m pi x by L, this time sine square n theta plus b m n I by c m n I squared sine squared m pi x by L cos squared n theta plus sine squared m pi x by L sine square n theta into a dx d theta. Okay. Now for n not equal to 0 we get n m n I second set as the same a m n I by c m n I squared plus b m n I by c m n I squared plus 1 into L a pi by 2, and for n equal to 0 we get n m 0 I 2 as b m n I by c m n I whole squared L a pi. Okay. So now n not equal to 0, f star m n I 2 is 1 over rho h n m n I 2 integral 0 to 2 pi integral 0 to L f without the time, okay, without the time because it's harmonic, 1 by a delta theta minus theta star delta x minus x star sine m pi x by L sine n theta a dx d theta. Okay, this is U3 Mn of the second kind because the force is in the U3 direction. Okay, so this now is equal to, these deltas work appropriately. I have f by rho h n m n I second into sine m pi x star by L sine n theta star, and this covers n equal to 0. Okay, so that means what? If I simply set n equal to 0, I get the correct result. So f m 0 I 2 is equal to 0. Okay. Now what about the response, each of them? What about the response? Okay. Response here is u x second kind is triple sum I m n f m n I 2 star, okay, then e to the power j omega t divided by the frequency term, which is omega mn I square minus omega square plus j 2 zeta mn omega mn omega, okay, and then the mode shape. So this part is now eta mn, and then the mode shape, which is a m n I by b m n I cos m pi x by L sine n theta. Then u theta 2, u theta of the second set is same I m n, let me remove this, f m n I 2 star, then e to the power of j omega t by this frequency term, the same frequency term, into the mode shape, which is minus, that you should remember, Bmni by Cmni sine m pi x by L cos n theta. And U3 is triple sum F star Mni 2 e to the power j omega t frequency term sine m pi x by L sine n theta. Okay. So, now we have to put it together. Okay. So, let us try to put it together here. I have ux is equal to summation over Imn, I am going to shorten it Imn okay, from the first set. What did we get? From the first set we got f by rho h n m n I 1, okay, a m n I by c m n I cos m pi x by L cos n theta. I will put e to the power j omega t here, okay, it is a hindrance, then divided by the frequency term, okay. That also I will just put it as frequency term, okay, this term, okay. That is from the first set, okay. From the second set, what do you get? We get plus f by rho h n m n I 2 a m n I by c m n I just hold on, I am missing out something, hold on, okay. We get f by rho h n m n I sine m pi x star by L cos n theta star, and then a m n I by c m n I cos m pi x by L cos n theta divided by the frequency term, okay. This is the frequency term, I will keep it like that, frequency term, frequency. Then plus f, the second set, f by rho h n m n I second set sine m pi x star over L sine n theta star into a m n I by c m n I cos m pi x by L sine n theta. So we can elegantly put this on the left, I suppose, e to the power of j omega t. Okay. Then if we take common, we have sigma I m n, okay, f by rho h, okay, sine m pi x star by L, sine m pi x star by L, then cos m pi x by L, cos m pi x by L. We can take it out. Okay. So we have sine m pi x star by L, this is used up, then cos m pi x by L, this is used up, and so inside I have cos n theta star, cos n theta, okay, divided by n m n I 1 plus sine n theta star sine n theta divided by n m n I 2 and the frequency term. Harmonic, okay. So now what is it? If n is not equal to, n is not equal to 0, then n m n I 1 is equal to n m n I 2. You have seen that, okay. But when n equal to 0, they differ, okay. But when n equal to 0, this term is 0. The contribution from the second set is 0. Okay. So what we are going to do is that for the entire set, n m n I 1 is adequate, okay, because when you do first term n equal to 0, this term will not participate at all. So it is this term by rho h n m n I 1. Then when n equal to 1, 2, etc., then n m n I 2 and n m n I 1 are equal. So I can ignore this speciality and I can set my ux to be equal to summation over imn f over rho h, okay, sine m pi x star over L, cos m pi x over L, a m n I by c m n I, cos n theta minus theta star by n m n I 1 and the frequency term. Okay. So we are running out of time. I will stop here. Thank you.